In this video, we're going to learn about how to use probability experiments to know or determine when a result is fair or biased. And after going through this video, I guarantee that you will know when a result is fair or biased using probability experiments for your maths exam. So ensure you stay to the very end of the video. At the end, I'll give you guys a practice question, test your knowledge on this topic. But having known this, let's go into the details of the video. Now, let me get this typical question that involves these probability experiments to know when a result is fair or biased. Okay, let me get the question. Okay, guys, now let's look at this question. This is a typical question for using probability experiments to know when a result is biased or fair. And the question says the spinner on the right was spun 100 times. Alright, so this is the spinner. Okay, use the results in the table below to estimate the probability of getting each of these scores. Alright, now note that you need to do an experiment over and over again and count how many times each outcome happens. Alright, so basically when you must have done the experiment over and over again and counted how many times each outcome happens, that is frequency, you can then calculate the relative frequency using this formula. Alright, so this is the formula for relative frequency. I use our relative frequency. RF equals frequency over number, okay, of times. Number of times you tried the experiments. Okay, now note that you can use the relative frequency of a result as an estimate of its probability. Okay, note that for us to use the results in the table below to estimate the probability of getting each of the scores, all right, we need to apply this relative frequency formula. So let's do it. The relative frequency formula will go like this. We will divide each of the frequencies by 100 to find the relative frequencies. So let's begin with when the score is 1. So the relative frequency when the score is 1 will be 3 over 100. All right, so 3 over 100 will give us what? 0.03. okay, relative frequency when the score is 2 will be 14 over 100. So 14 over 100, when you punch in the calculator, we have it to be 0.14. Okay, relative frequency when the score is 3 will be 41 over 100. So when you punch it in the calculator, then you have it to be 0.41. Relative frequency when the score is 4 will be 20 over 100. When you punch it in the calculator, then you have it to be 0.2. Relative frequency when the score is 5 will be 18 over 100. When you punch it in the calculator, you're going to have it to be 0.18. And lastly, relative frequency when the score is 6 will be 4 over 100. When you punch it in the calculator, you're going to have it to be 0.04. Okay, now note that the more times you do the experiments, the more accurate your estimates of the probability should be. Okay, now if the relative frequency of a result is far away from what you will expect, then you can say that the dice or spinner or coin used is probably biased. If not, you can say is probably not biased or it seems fair. So take note of this, guys, very important for this experiment. All right, what if after solving this problem, after getting these various relative frequencies, and you are asked, do the above results suggest that the spinner is biased? All right, now merely looking at this result have here, the answer will be yes. All right, because the relative frequency of theory, look at it, we have it to be 0.41. When the score is 3, the relative frequency is what? 0.41. Okay, so this relative frequency is much higher than you would expect. while the relative frequencies of other scores 1, 2, 4, 5, and 6 are much lower. Okay, now note for a fair six-sided spinner, you would expect all the relative frequencies to be about the value of 1/6, which is the same thing as 0.166. You keep having repeating decimals. All right, now it's only when the score is 3 that its relative frequency is 0.41, which is much higher than you would expect. All right, for a fair six-sided spinner. Okay, because for a fair six-sided spinner, you would expect all the relative frequencies to be about this value. All right, 0.1. All right, every other value here is within, for the score is within 0.1, 0.0, 0.1, 0. This one is 0.2. It's only this 3 score that is much higher. All right, so the above results suggest that the spinner is what? Biased. Okay, so that is for using probability experiments to know when a result is biased or fair. Now let me give you a mass practice question on this to test your knowledge, and after you can call it a class. Let me give you a similar question. Let's write this. Okay guys, now look at this mass practice question on this probability experiment. The question says Sandro rolled a dice 1000 times and got the results shown in the table below. Find the relative frequencies for each of the scores. Do the results suggest that the die is biased? All right, so feel free to pause this video and see if you can figure this out or attempt it. Okay, let's do it together. Now for the relative frequencies, all right, now let's go. When the score is 1, the relative frequency will be 140 divided by 1000. Remember, we have 1000 times. This time I was not 100. So when you punch this in a calculator, you're going to have it to be 0.14. When the score is 2, we have 137 divided by 1000. All right, when you punch it, you're going to have it to be 0.137. When the score is 3, we have 138 divided by 1000, which will give us, when you punch it, is 0.138. When the score is 4, we have 259 divided by 1000. When you punch it, you're going to have 0.259. When the score is 5, we have relative frequency to be 161 divided by 1000, which will give us 0.161. And last, when the score is 6, we have 165 divided by 1000, which will give us 0.165. All right, so this is for the A part of the question. These are their relative frequencies. Now the question B part of it says, do the results suggest that the dice is biased? Now the obvious answer is what? Yes, because the relative frequency for when the score is 4, we have it to be this value, 0.259. all right, which is much higher than you would expect from a fair dice, which is 1/6 or 0.166. okay, you keep having repeating decimal. All right, so that will be the answer to this question. Okay, so it's as simple as that, guys. Hope there's something interesting from this video. Now if you are new to the channel, ensure you check the description of this video below for link to our Telegram channel. Click on it and join the Telegram channel for instant notifications. Also ensure you are subscribed to this channel by hitting the subscribe button for more videos like this. Like, share, and comment on this video. Tell me how you feel from what I learned from this class. If you seem to have any specific question to ask regarding this relative frequency to know when the result is biased or fair, feel free to leave a question in the comment section below and I will ensure to give you a response. That's it for this class. Now click on the end screen above and I see you in the next video. Thanks for watching.